Hi, Math 34 students. This is Module 7, Example 2 on page 135. We will have covered Example 1 together in class, but make sure that you have read the vocabulary for Module 7. So earlier in the semester, we learned about the 68, 95, 99.7% rule, about the standard deviations, and now we're going to use that information to find the cutoff values for any data set. So let's consider rolling a six-sided die. What's the probability that the roll is a 5? And what is the probability that the roll is not a 5? So the probability of rolling a 5 is 1 out of 6, or as a decimal we could put 0.1666666 or round it to 0.167. The probability of rolling not a 5, so we say probability of not 5, equals 5 out of 6, right? Because 5 out of 6 of the sides will be different numbers. And as a decimal, that's 0.833, and the 3's keep on going, but we'll round it to 3 decimal places. So now, suppose you roll a die once every day for an entire year, and we're going to assume 365 days in that year. We want to calculate what is the expected amount of 5s that you will roll in the entire year. So the expected value is the number of rolls times the probability. So we say n times p. So it's going to be 365 rolls times 1 out of 6, which is our probability of a 5. And that works out to be 60.83. Now in this calculation I used the fraction 1 out of 6. If you used your decimal approximation from above, that's approximately 365 times 0.167, which would work out to be 60.9, I think. So remember, if you use the decimal approximation, you're going to get a slightly different answer. So it's going to be more accurate to use the fraction on your calculator. So we expect in an entire year to roll 60.83, or about 61 5s. Question C asks us, what is the expected amount of not 5s you will roll that entire year? So again, we can calculate n times, instead of p, we'll say 1 minus p, which is the probability of not 5. So that will be 365 times 5 out of 6. And if we calculate that, we get 304.167. Another way to see this is we could have said 365, subtract our answer from part B, 60.83. And that would total the 304.167 that we got here. And you might have to put another 3, so go add another decimal place and you'll get that answer. So question D asks, is the sample size n, in this case n equals 365, large enough that we can use a normal distribution shape? Show your calculations. So we have to calculate out np, or n times p, which we actually just calculated above in part B, so that was 60.83. And you'll remember from vocabulary, we have to check to make sure that this value is greater than 10. And this is in fact greater than 10. We also have to check n times 1 minus p, which we just calculated. It's the same calculation whether I put the star or not. So above I said star for multiplication. Star, parentheses, or just saying n times that value is the same calculation. And we calculated that to be n times 1 minus p as 304.167, which is also greater than 10. So yes, we can use the normal distribution. So anytime we want to use a normal distribution, we have to check n times p and n times 1 minus p to make sure that those totals are greater than 10. If our calculation is less than 10, then we're going to run into an instance where either the sample size isn't big enough or the probability isn't big enough, and we cannot use the normal distribution. Now for question E, let's go ahead and calculate out the standard deviation. So you can use the square root on your calculator. I'm going to type SQRT for what goes inside the square root. And I'm going to use these brackets to show you what's going to go inside the square root. So on the top of the square root, we're going to have 1 over 6, which is the probability of 5, times 5 out of 6, which is the probability of not 5, or 1 minus p. And we're going to divide all that by 365. And when you type in your calculator, you want to make sure all of that is inside the square root. And so when we calculate that out, we're going to get 0.0195. And that's our standard deviation, or SD for short. So now question S says I asked 15 friends to roll a die 365 times each and count the number of rolls that were 5s. I use this data to calculate the sample proportion p hat equals 75. So actually there's a typo here. P hat should equal 75 out of 365. I left off some calculations there. And if we make it a decimal, that would equal 0.205. So make sure you fix that. So now we want to calculate this 95% confidence. So remember, 95% confidence is within 2 standard deviations. So we can calculate the lower bound by saying our p hat value, 0.205, minus 2 times the standard deviation. So our standard deviation is 0.0195. And that gives our lower bound, which is 0.166. Similarly, we can calculate the upper bound by adding 2 standard deviations. Okay, so our upper bound is 0.244. So we can construct a 95% confidence interval is from our lower bound 0.166 to our upper bound 0.244. And we write it in this interval notation with the parentheses. So this means that we're 95% confident that if you run it 365 times, the proportion that you get will fall, the actual proportion will fall into this range. Okay, go ahead and work on the group assignment, and remember to participate in the group assignment forum.